This video complements test drilling trees and includes a recap on how to identify a suspicious tree, how to treat a basal nest that is inside of a tree, and how to protect that tree once complete. Let's quickly recap on why you would treat a basal nest inside of a tree if found. So a basal nest or a hypogeal nest extending into a tree causing tree piping can be caused by a number of economically significant termite species, including Coptotermes, Shedorhinotermes, Mastrotermes, and some Nasutotermes species, as you can see in the picture. Tree piping will cause significant vulnerabilities to a tree, which can result in the tree collapsing onto a property, onto utilities, surrounding structures, and having the presence of termites will increase the termite pressure to the property that you are servicing on site. So again, to recap, the nest will most likely be located at the root crown of a tree, extending as high as 1 to 1.5 meters up the tree, which can be in the heartwood or in the sapwood of the tree. On many sites, it will be unfeasible to test and drill every tree on site, so you need to identify suspicious trees with evidence of other timber pests such as borer, or previous or current larva feeding, previous or current termite leads, wood decay, or even carpenter ants. This is an at-risk tree, as we've discussed before. Remember, you can palpate the tree for any evidence of termite workings. You can also be looking for evidence of your ground mound nests or arboreal nests. Remember to always be looking for live casts, as this is very good evidence that you have a reproductive nest nearby that may need treating to reduce the termite pressure to your customer's property. During your site inspection or test drilling methodology, you may confirm the presence of a subterranean termite nesting in or around a tree. You then need to ask yourself, is this nest posing a risk to the building and should I treat it? We don't want to be treating subterranean termite nests that aren't posing a risk to the building, either based on their location or the species of termite. For example, if you find a tree that is on Crown-owned land or in an adjacent property owner's land, you may not have permission to treat that tree. Once you have determined if this nest is both ethical and feasible to treat, prepare your costings and gain permission from your customer. Next, you'll need to gather the equipment you'll need to complete the task. The PPE you select will be based on your risk assessment of the site and the task ahead of you. Consider how you can protect yourself from the hazards you identify, which may be chemical, dust, or from the electrical equipment you're using. The application equipment you select is best off being battery operated, as that way you can access the trees easier. You also need to select an appropriate drill and drill bit, as well as the products you will need to close the hole once complete, which can be acrylic caulking compound or timber putty, wooden dowels, and a fungicide. Select the methodology you wish to confirm or deny the presence of termites, either a boroscope, a blade of grass, or the use of a thermometer. Let's quickly recap the methodology of tree test drilling. Drill at a 45-degree angle into the root crown of the tree, feeling for any give as you may enter tree piping or termite workings. Remember, if you don't find any tree piping, nest, or termite gallery systems in the root crown, drill a little higher, at least 1 to 1.5 meters above the root crown. Boroscopes can easily confirm the presence of live case and workings in a tree, but are expensive. Next, you need to prepare the timidicide as per the label of the product you have selected. Wear the correct PPE. Shane here chooses to have a beard, so wears a PAPR system. Insert and inject the timidicide as per the label, looking for areas where the timidicide may be leaking through flight holes or exit holes. The volume of timidicide to inject into the tree depends on the diameter of the tree. For trees under 1 metre, 10 to 20 litres should be sufficient. For trees over this size, may need up to 40 litres injected into the base of the tree. For trees that contain an arboreal nest, you may also need to trench around the root crown of the tree, remove any nesting material, flood with timidicide and backfill, as well as remove any external leads from the tree. Once that task is complete, you now need to protect the tree from any future fungal attack. Insert a registered fungicide. Use some wood putty to seat the wooden dowel into your test drill hole. Ensure the wooden dowel is flush with the external part of the tree. Finally, cover over with some more wood putty. In summary, you've learned how to identify at-risk trees, recap how to confirm the presence of subterranean termites, determine what nests need treating and why, treat an infested tree with liquid formulation, and protect a tree from future fungal attack.